In this video, we will discuss Section E of Sample Question Paper Class 12 Mathematics as released by the CBSE Board for the coming 2024-25 exams. This section consists of 3 case study or passage-based questions of 4 marks each with subparts. The first 2 case study questions have 3 subparts of marks 1, 1, 2 respectively. The third case study question has 2 subparts of 2 marks each. So, by solving section E completely, you can get maximum 12 marks. Hello friends, welcome to channel Number Collage. This channel is dedicated to videos on a wide range of mathematical concepts and problems related to them, ranging from high school math to engineering math. Effort has been made to explain the concepts through basic mathematical ideas in a simple English. Hope you will like my effort. Thank you. Section E comprises of 3 case study or passage-based questions of 4 marks each with subparts. The first 2 case study questions have 3 subparts of marks 1, 1 and 2 respectively. The third case study question has 2 subparts of 2 marks each. First we will see case study 1. In this, first question is question 36. Ramesh, the owner of a sweet selling shop, purchased some rectangular cardboard sheets of dimension 25 cm by 40 cm to make container packets without top. Let X be length of the side of the square to be cut out from each corner to give that sheet the shape of the container by folding up the flaps. Based on above information, we have to answer following questions. Number 1. Express the volume V of each container as a function of x only. Number 2. Find dV by dx. Number 3. A. For what value of x the volume of each container is maximum. And there is option to this question B, where we have to check whether V has a point of inflection at x equals 65 upon 6 or not. First we will draw possible shape of the box, which would look like this. This x will be height of the box. In the first question, we have to express volume V of each container as a function of x only. Volume of container will be length into breadth into height. Its length is 40 minus 2x, breadth is 25 minus 2x, this one, into height x, this one. Expanding, this will be x into 1000 minus 80x minus 50x plus 4x square, and the volume in terms of x will be 4x cube minus 130x square plus 1000x. So this is answer 1. In the second question, we have to find dV by dx. Number 2, dV by dx will be d by dx of 4x cube etc., which will be 12x square minus 260x plus 1000. So this is our answer 2. Question 3a, we have to find for what value of x volume of each container is maximum. Number 3, here we will use second derivative test for finding maxima. So for extreme values we have dV by dx equals 0, therefore 12x square etc. equals 0. We will solve this equation and find x. Dividing throughout by 4, this will be 3x square minus 65x plus 250 equals 0. Factorizing by splitting the middle term, 3x square minus 15x minus 50x plus 250 equals 0. 3x into x minus 5 minus 50 into x minus 5 equals 0. X minus 5 into 3x minus 50 equals 0. That gives x equals 5 and x equals 50 upon 3. Let us find second derivative of volume d2v upon dx square, that will be d by dx of dv by dx 12x square, etc., which is 24x minus 260. Now for x equals 5, it will be 24 into 5 minus 260, 120 minus 260, which is negative. And this implies volume V is maximum when height of the box x is 5 centimeter. This is the answer. We have obtained dv by dx as 4 times 3x square minus 65x plus 250, and it exists at x equals 65 upon 6 because this is going to be a real number. Now d2v upon dx square will be d by dx of dv by dx, that is 4 times minus 65x plus 250, which will be 4 into 6x minus 65. Now d2v upon dx square at x equals 65 upon 6 will be 4 into 6 times 65 upon 6 minus 65 will be 0. Now let us check what happens to d2v upon dx square to the left of 65 upon 6 negative. It will be 4 times some quantity q less than 65 minus 65, which will give a negative quantity, and d2v upon dx square at x equals any value to the right of 65 upon 6 plus will give 4 times any quantity q greater than 65 minus 65, which will be a positive quantity. Since the values of d2v upon dx square changes sign to the left and right of x equals 65 upon 6, we say that it is a point of inflection. Case study 2, question number 37. An organization conducted by Chris under 2 different categories of boys and girls. In all, there were 250 participants. Among all of them, finally, 3 from category 1 and 2 from category 2 were selected for the final race. Ravi forms 2 sets B and G with these participants for his college project. Let B equals 3 boys B1, B2, B3 and G equals 2 girls G1 and G2, where B represents the set of boys selected and G the set of girls who were selected for the final race. Ravi decides to explore these sets for various types of relations and functions. On the basis of above information, answer the following questions. Number 1. Ravi wishes to form all the relations possible from B to G. How many such relations are possible? Sub-question 1. Number of relations will be number of subsets of the Cartesian product B cross G, which is equal to 2 raised to number of boys 3 into number of girls 2 to the power 6, that is 64 number of relations are possible. Second question, among all these relations, how many are functions from B to G? Answer to the second question, number of functions possible will be number of elements in codomain, that is number of girls, to the power number of elements in domain, that is number of boys. This will be 2 cube or 8. So 8 number of functions are possible. Now we solve the third question. In third question A, we have to find total number of 1 and onto functions which can be defined from B to G. Answer to the third question A. For 1 function, number of elements of domain and codomain should be same, but here number of elements of codomain, which is 2 girls, is less than number of elements of domain, which is 3 boys. Hence no 1 function can be formed. Next we have to find number of onto functions. For onto function, every element of codomain, which in this case is set G consisting of 2 girls G1 and G2, must be related to at least one element of the domain, which is set of boys B consisting of 3 boys B1, B2, B3. So we have to subtract 2 possibilities as follows. from the total number of functions possible, and these possibilities are: every boy is related to girl G1, that is, girl G1 has pre-image B1, B2, B3 in domain set. Also, every boy of domain is related to girl G2 of the codomain G. That means girl G2 from codomain has a pre-image B1, B2, B3 in domain set. So, number of onto functions will be total number of functions possible, which we have already found out above, to cube minus these two possibilities that we have just discussed. So, in all, number of onto functions will be 8 minus 2, that is 6. Case study 2, question number 37, optional question 3b. If the track of the final race for the biker B1 follows the curve x square equals 4y, where x is between 0 and 20 root 2 and y is between 0 and 200, then we have to state whether the track represents a 1 and onto function or not, and we have to justify our answer. The track of the final race is defined as x square equals 4y, which is y equals x square upon 4. We have to check whether the track represents a 1 function. For that, we will assume two numbers x1 and x2 belonging to the closed interval 0 and 20 root 2, such that f of x1 equals f of x2. From 1, we can write x1 square upon 4 equals x2 square upon 4. That implies x1 square equals x2 square. x1 square minus x2 square equals 0. x1 minus x2 into x1 plus x2 equals 0. x1 minus x2 equals 0 gives x1 equals x2, and since x1 and x2 belong to closed interval 0 to 20 root 2, we can conclude that fx equals x square upon 4 is a 1 function. Now we will check whether the track function is onto function. We are given y lies between 0 and 200, which is a non-negative value of y, and track equation x square equals 4y gives us x equals 2 root y. Now from the track function y equals x square upon 4, that is f of x equals x square upon 4, replacing x by 2 root y, we get f of 2 root y equals x square upon 4, which is y. Now here, for any arbitrary y belonging to closed interval 0 to 200, pre-image of y exists in closed interval 0 to 200. Hence, we conclude that function f of x, x square upon 4, is onto function. So the track function is both 1 and onto. Case study 3, question 38. Arka bought 2 cages of birds. Cage 1 contains 5 parrots and 1 owl, and cage 2 6 parrots. One day, Arka forgot to lock both cages, and 2 birds flew from cage 1 cage 2 simultaneously. Then 2 birds flew back from cage 2 cage 1 simultaneously. We have to assume that all the birds have equal chance of flying. On the basis of above information, answer the following question. First, we will write the data given. Cage 1 has 5 parrots and 1 owl. Cage 2 has 6 parrots. Let A be the event that parrot and owl fly from cage 1. B be the event that 2 parrots fly from cage 1. C be the event that the owl is still in the cage 1, and D be its complementary event that owl is not in the cage 1. Further, it is given that 2 birds fly from cage 1 to cage 2 simultaneously, and 2 birds fly back from cage 2 to cage 1. Question 1. When 2 birds flew from cage 1 to cage 2 and 2 birds flew back from cage 2 to cage 1, then we have to find the probability that the owl is still in cage 1. So for the answer 1, we have number of elements of A intersection C is equal to 5C1 into 1C1 multiplied by, when two birds fly from cage 1 to cage 2, there will be 5 plus 2, 7 birds in cage 2. So 7C1 multiplied by 1C1, that will be 5 into 1 into 7 into 1, 35. Next, number of elements of A intersection D when owl is not in cage 1 will be 5C1 into 1C1 into 5 plus 2, 7C2, which is 5 multiplied by 1 into 7 into 6 upon 2, 5 into 21, 105. Next, number of elements when two parrots fly from cage 1 and owl is still in cage 1, that is B intersection C is 5C2 into 5 plus 2 plus 1, 8C2, which is 5 into 4 upon 2 into 8 into 7 upon 2, which is 10 multiplied by 28, 280. And number of elements of the event that two parrots fly from cage 1, that is B intersection the owl is not in cage 1, that is D, will be 0. So number of sample points will be n of s 35 plus 105 plus 280 plus 0, 420, the total sample points. Now to answer the first question, probability that owl is still in cage 1 is P of C equals P of A intersection C plus P of B intersection C, which is sample points 35 plus 280 upon total sample points 420, which is 315 upon 420, 3 upon 4. Second question, when two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1, the owl is still in cage 1, then what is the probability that one parrot and the owl flew from cage 1 to cage 2? Number 2, we have to find the probability, which is a conditional probability, that one parrot plus one owl flew from cage 1 to cage 2 given that the owl is still in cage 1. This will be probability of event A when event C has already occurred, which is probability of A intersection C upon probability of C, which is probability of A intersection C upon probability of A intersection C plus probability of B intersection C, which is 35 upon 420 upon 315 upon 420, 35 upon 315, which is 1 upon 9. So answer to the first question is 3 upon 4 and answer to the second 1 upon 9. Friends, if you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.